Good morning. This is your stats sensei, Mr. Spensey, and we're going to go over scenario 3. A credit card company wondered whether giving frequent flyer miles for every purchase would increase card usage, which has a current mean of 2,500. All right, so we have a mean of 2,500. That sounds like it might be a population, but we need to read farther. They gave free miles to a simple random sample of 36. Okay, so we know we have a sample of 36. That might be important. Credit card customers and found the sample mean to be 2542. Okay, so we now have some clarification. 2,542 is our X bar. That came from the sample of 36. All right, and we have a population standard deviation of 109. It's important to know the population standard deviation because that knows that we could work with a normal if it meets the other criteria. Well, they didn't tell me it was normal, so that might be a problem, but we have a sample size of 36, so we should be okay. So the very first thing is we need to identify the test. Well, since we know that our sample size is 36, this is going to be a Z interval for means. Right? So that's what I'm going to be working with. So it says create a 95% confidence interval and comment whether or not this provides evidence that the mean credit card usage increased. Okay, so first off, first thing it says on our recipe is parameter 1 is to define the parameter, which is let mu equal the true population mean credit card usage. Technically, the credit card usage is after they offered the free miles. All right, so the true population mean credit card usage after the free miles were offered. Now, we're not going to write all that in our conclusions, but that's what it was. The next thing we need to do is our conditions. Well, our first condition is random sample. In this case, we have a random sample of 36, and that was given. So we'll go ahead and put a check mark by it. They told us that. The next thing they said was, the next thing we need to check is whether or not the N is less than 10% condition. So we're going to do that fairly quickly here. So our sample size was 36. So N equals 36. So we're going to multiply by 10. So 36 times 10 equals 360. And we're going to believe that that 360 is less than the total number of card users. Because I'm sure that there are more than 360 credit card users. All right, so less than the total number of total pop of card users. All right, so probably should have used population here. So let's do that. Total pop of card users. Number 3 is normality. Well, they didn't tell me it was normal, but they did give me a sample size, and the distribution of means is normal if it's greater than 30. So N equals 36 is greater than or equal to 30. The distribution of means is normal by central limit theorem, by CLT. All right, the next thing we need to do is we need to go ahead and calculate our data. So our confidence interval formula is basically X bar plus or minus Z star, the standard deviation of the population divided by the square root of N. So let's start plugging in what we know. Well, we know the sample mean, which is 2,542. So 2,542 plus or minus, we don't know Z star, so we're going to leave a pretty good space for it. Our standard deviation for the population was 109, so we're good with that. And we know our sample size is 36. So we have all of that, but we need the Z star? Well, we get Z star by doing an inverse norm, because basically we're working with an area that we need to know of 95%. So 0.95. So this is going to be an inverse norm. Calculator is going to ask for the area, that's 0.95. Then it's going to ask for the mean. Well, because we're talking about a Z-score, the mean is 0 and the standard deviation is 1. And when I go about running that, I go second vars, inverse norm, area 0.95, mean is 0, standard deviation of 1, make sure it's on center. And I end up getting about 1.96, specifically 1.9599. So 1.9599. All right. So the next thing we need to do, we've input all the information. Now we need to go ahead and run the interval. To do the interval, we're going to have to go to stats test Z interval. So when we do that, stat test number 7 is Z interval. Press enter. Make sure stats is highlighted because we're not inputting data. Well, our standard deviation for the population was 109. Our X bar was 2542. Our sample size was 36. And our confidence level in this case was 0.95. It says calculate. And so we end up getting 2506.4 and 2577. 2506 and 2577. I just rounded that. Here's my lower, here's my upper. Now, please remember, prior to offering the air miles, they had $2,500 worth of usage. So we know it moved up. The question is, adjusting for randomness, is this statistically significant? And the fact is, yes, because the 2,500 is actually below that. So it is statistically significant, but we'll deal with that in a moment. The next thing we need to do is we need to write our conclusion about what we found. And what we can say is we are 95% confident that the true population mean credit card usage after the free mile offer lies within the interval 2,506 and 2,577. All right. So that's our conclusion. The next thing we need to do is explain what the confidence level is. By the way, this was number 9, and then number 10 on the recipe is explaining the confidence level. And the confidence level is, hey, if we did this over and over again, so in repeated sampling, we expect this method to capture the true population mean card usage %95 of the time. Please note, true population mean credit card usage, true population mean credit card usage. That was all in our very first step where we defined the parameter. Okay, and now we need to discuss whether or not this provides evidence the mean card usage increased. Well, here's what we know. Our interval is 2506. That's above the 2,500. So there is evidence to suggest card usage increased. Why? Well, because the interval is above 2,500. All right. So there is evidence that suggests card usage increased because the interval is above 2,500. All right. The very last part of it. It says create a 99% confidence interval and comment whether or not this provides evidence. All right. Well, we're not going to have to go through everything else because we've done it. So let's check on that. So our formula is X bar plus or minus Z star standard deviation square root of n. Well, our X bar is 2,542. We don't know what our new Z star is because we have a different Z value, but our standard deviation is still 109, and we still have a sample size of 36. So if that's what we had and we went to run it, we'd go second vars, inverse norm, 0.99, and we find out that we have a Z score of about 25,758. 2.5758. So let's go ahead and run this thing. Stat test number 7, Z interval. And I just need to change my confidence level because I have everything else in there. There's my standard deviation. There's my X bar. There's my sample size. And this time I have 2495 as my low value. And my upper bound is 2588. Well, that's interesting because now I know that 2500 lies within this interval. So there is not sufficient evidence at 99% confidence because the 22,500 lies within the interval. All right, I hope that helps with today's notes, and I will look forward to seeing you on the next one.